Hi, my name is Alyssa Pham, and I will be presenting Comparison of Rates, Question 3. The following data were obtained on post-surgical infection rates. Are we having more infections than expected from the patient's conditions? First up, we copy the data into an Excel spreadsheet. Then we calculate the expected rate of infection for each week. This is found by calculating the average risk of infections of all patients during that week. Next, we calculate the expected deviations. The first step to find the expected deviations is to calculate 1 minus the risk of infection for each patient, which is denoted as P. Then we multiply these values in the risk of infection for each patient. We then sum these products and take the square root. Finally, divide the square root by the number of patients in that time period. For example, in the first week, we take the sum product of the risk of infections of each patient in week 1 and in week 1 of the 1 minus P table. Take the square root of this product and divide it by the number of patients, which in this case is 6. Repeat these steps for each week. Note that it is important to use the count A formula in order to count the number of cells that are not empty. Then we create a column for the number of cases or patients in that week. For example, the number of cases in the first week is 6. We then find the one-sided t-values for each time period by entering the degrees of freedom and significance level. To find the degrees of freedom, subtract 1 from the number of cases in each week. Our significance level is set to 0.05. For the first week, our degrees of freedom is 5. And the significance level is 0.05, which gives us the t-value of 2.015. Next, we calculate the upper and lower control limits. The upper control limit is found by taking the expected rate of infection and adding the product of the t-value and expected deviation for each week. The lower control limit is calculated by subtracting the product of the t-value and expected deviation from the expected rate of infection for each week. Once we find our upper and lower control limits, we set the limits that are above 1 to 1 and limits below 1 to 0. Next, we calculate our observed rates. This is found by taking the expected rate of infection and divided by the number of cases for each week. For example, in the first week, we take 6 from our number of infected and divide it by 6 from the number of cases. Finally, we plot our data, where the upper and lower control limits are in red and the observed rates are in blue. Our time period is on the x-axis and the infection rate is on the y-axis. Based on this control chart, there is a decrease in the rate of infections in week 2, followed by an increase in week 3. The infection rate decreases from weeks 3 to 5 and finally plateaus at week 6. There is no point at which we are above the upper control limit, and therefore we are not having more infections than expected. All time periods are within our control limits. This concludes my presentation, and thank you for your time.